Hey SM3, this week is 3.4 factoring polynomials. So we've already done some factoring and we did that right before the beginning of Unit 3. So hopefully that will help you here. This will require a bit more advanced concepts, thinking, and strategies. So it might be more difficult and not like what you might be used to. So let's review a little bit of things right here. Also, if you do feel like you understand how to factor all of these, go for it. Try it on your own and see if you can do them. But if you feel pretty good on your factoring skills, then feel free to just jump through all of these examples, because that's pretty much all I'm going to be doing in this video, is doing all these examples. And if anything, if you feel like you're good on your factoring at any point after doing a couple practice problems with me, just jump down here to the factor theorem. So just skip ahead of all these problems that I'm doing, and you can jump to the part where I talk about the factor theorem. So that might be the only thing. So this will be probably a lengthy video because I'll go through all the examples just so everyone feels like they know how to factor these. Okay. So, but if you feel like you're fine, then skip through the most of this. So, just some things that I want to point out that these are equations that will be useful whenever you're factoring. Okay, so it's helpful to recognize patterns of what we see here because it helps us to factor. And here are some examples on the right hand side. So, for instance, if I notice I have something like this right here, I have x squared minus 9. Well, the thing is that if I FOIL this out on the right side right here, if I were to multiply this out, well, that's going to be x squared right there. That's going to be minus 3x. This is going to be positive 3x, and that's going to be 9. Okay? So whenever you see something like this right here, where you have an x plus 3, and then, or like x plus a and x minus a, whenever you see something like that, well, it's just going to be, if you were to multiply it out, since these terms cancel right there, then this is just going to be x squared minus 9, or in other words, x squared minus 3 squared, okay? So there's a pattern here that you should be able to see, and it's helpful to notice these type of patterns, okay? So it's pretty much what all of this is saying right here. So if I ever see something like this right here, that displays a pattern of this being squared and that being squared, like over here, well, 6 is just the same thing as 2 times by x times by 3, right? And then that would be plus 3 squared and x squared, right? So do you see how this is similar to this right here over there? So pretty much we're just saying that we can use shortcuts. That's what all these are really saying, okay? So if I see something like this and I can recognize the pattern that's over here, well, I know that I can factor this out to be x plus 3 squared. And that's the same with all of these, okay? So just trying to recognize patterns is what it's pretty much trying to get you to do. So I'll go through some example problems. We'll go through quite a bit of example problems. So if you feel like you know them, then you can skip through all of these or whatnot and go to the homework, but feel free to come back and reference these if you get stuck on any of your homework problems. So for number 1, 1 through 14, it says to factor the polynomial completely. Okay, so you want to factor as much as you can. So first thing that's always good to do is recognize if there's any common factor between all the terms in your polynomial. So in this case, every term here has a 20 and it has an x, at least one x, okay? So that's the first thing you want to do. A greatest common factor between all terms. If you can, factor that out. So I'm going to factor out the 20x. So 20x cubed divided by 20x is going to be x squared. And then minus, well, 220 divided by 20 is 11, and x divided by x, x squared divided by x is x, so that would be that. And then 600 divided by 20 is going to be 30, so then this will be plus 30 right there. Now, can I factor this out a little bit more? And the answer is yes. So I can break this up into factors. So I still have the 20x out here. Now, in order to factor this, I need to think of two numbers that add to be negative 11 and multiply to be 30. And those two numbers would be negative 5, so x minus 5, and x minus 6. So minus 5 minus 6 is equal to negative 11, which is what I have right there. But then when you multiply them, negative 5 times negative 30, or negative 6, sorry, I get positive 30. Okay? And so these are the numbers, negative 5 and negative 6 are the numbers that make up my factor right there. For number 2, okay, this one's a little bit more difficult, and we're going to need to look at the patterns that we talked about before. So first thing, again, I notice that I can factor out an m from both of these right here. So I can take out an m. So let me take out an m, and left behind will be m to the 4th minus 81. Okay? Now, it's kind of tricky to see, but I'm going to rewrite this in a way, because I want to get this to match one of these up here. And I want it to match, let's see, this one right here. So a squared minus b squared. I want to try and see if I can get it to match something like that. So can I change these terms to be something squared and something squared? It's pretty much what I'm going to try and do. And so there is actually a way I can rewrite this. So I'm going to rewrite this to be m, but instead of saying m to the 4th, I can rewrite this as m squared squared. Because m squared squared is m to the 4th. And then I can also rewrite 81 to be 9 squared. Okay? So now I have a pattern that I'm familiar with right here, where I have two items that are being squared and subtracted. They're being subtracted. Okay? So if I use that equation right here, then I know that my factors will be a plus b and a minus b. So I still have the m out here, so I'm going to factor this. This is m, but see here that instead of a, I have m squared, and instead of b, I have 9. So I'm going to have m squared plus 9 and m squared minus 9. Okay, so that's the pattern up here. So I have two terms, and they're both being squared. The operation between them is subtraction. So then I have a plus b and a minus b. So I have a, which is m squared, and then b, which is 9. Okay? And now I can even go a little bit further, because I can see that there's another similar pattern right here. So this can be written as m squared minus 3 squared. Okay? So I can, and then this can break down into two factors of m minus 3 and m plus 3. So just like that. So m minus 3 and m plus 3. Let me rewrite that. So m minus 3 and m plus 3. Okay, so I just broke that down into that part right there. So all my factors together are m squared plus 9, m minus 3, and m plus 3. So it's kind of tricky to see those patterns, but the more you do it, the more you get familiar with it. So let's try number 3. So again, we're going to look for a pattern. So let's look up here. So this is being cubed, that's being cubed, and being added right there. So I want to look for a pattern like this one right here. So can I change the variable here to look like that? So I have an a cubed and an 8 cubed, but this right here, these items right here aren't being cubed, but I can make them so they are. So this is equivalent to 27 is equivalent to 3 squared. So I can change this to be 3a being cubed, because that is the same thing as 27a cubed plus 2b cubed, because 2 cubed is 8. So now, since I knew that, I can break this up into something that looks like that, where a is 3a and b is 2b. So now this is equal to a plus b, so 3a plus 2b multiplied by, let me check it up here, a squared minus ab. So a squared, which was 3a squared, minus ab. So a is 3a, and b was 2b. So minus ab and then plus b squared. So in this case, b is 2b. So then plus 2b squared. And I'm actually going to move this down over here. Okay, so I have my factor 3a plus 2b. Now I can simplify this a little bit more. So 3 squared is 9, so I have 9a squared here. So I have 9a squared minus 3 times 2 is 6, so I have 6ab. And then 2b squared is the same thing as 4b squared. And there you go. That should be it right there. So these are two different factors like that. Alright, let's try number 4. So this one won't require any patterns here, but it will require a technique of factor by grouping. So I'm not sure if you remember this from SM2, but factor by grouping means that you look at something, you look at the polynomial with 4 terms, so 1, 2, 3, 4. This is a polynomial with 4 terms, and you try to factor it by halves. Okay, so let's look at the first half where I have 5t to the 6th power plus 2t to the 5th power. Is there anything that can be factored between these two terms? And the answer is yes. You can factor out a t to the 5th power. And then left behind will be 5t plus 2. Now jump over here. Is there something in common over here? Well, I know that there's a t cubed. So I'll take out a negative, because these are both negative. So I'm going to take out a negative t cubed. And left behind will be 5t, that should be it, 5t. And then instead of minus, because we factored out the minus, this is now going to be a plus sign. So plus 2. That's what's left behind. Okay. So we went from having 4 terms, so 1, 2, 3, and 4, but now we only have 2 terms. This is 1 term, and this is a 2nd term. Okay, so now we only have 2 terms, and both these terms have a common binomial factor. So this is a binomial. 5t plus 2 is a binomial, and it's a factor. So we call this a common binomial factor. Meaning, we can take out the 5t plus 2 from both of these terms. So now I have 5t plus 2 as 1 term, so whenever I get rid of those, I'm only left with t to the 5th power minus t cubed. And there you go. But you could even factor this out a little bit more, because this right here, So that can be factored. I can take out a t cubed. So if I take out the t cubed, then I have t squared minus 1. Okay, now this right here, this should look similar to a pattern. Okay, 1 squared, we can rewrite that as being 1 squared, right? Because 1 squared is 1. So if we look up here, we're again back to seeing this pattern right here. Something being squared minus something else being squared. So this is equal to t cubed, t plus 1, and t minus 1, using that pattern. Okay, so we broke this down into that. So overall we have 5t plus 2 times by t cubed times by t plus 1 times by t minus 1. For number 5, let's see right here. So from here, I'm going to use a method of substitution. Okay? So I've noticed here that this is y to the 4th, this is y squared, and this doesn't have anything, which is awfully familiar to having something like y squared, y, and 0. Okay? So I'm going to make a substitution. I'm going to say that y squared is equal to x. So when I do that, I can change my equation for a little bit. So if y to the 4th, if y squared is equal to x, then y to the 4th is equal to x squared. So I'll write that as x squared minus 13, and we said we're making a substitution. Y squared is equal to x. So 13x minus 48. Okay? Now, we know how to factor this. This is something that's not really anything new. So if I take 48, negative 48, and I try and break that down into factors, I'm trying to find a number that multiplies to be negative 48 but adds to be negative 13. So 48 can be broken down into 1 times 48, or it can be 2 times 24, or 3 times 16. Okay, now do any of these pair of numbers, could we add them to be negative 13? And the answer would be right here, it would have to be negative 16 plus 3. Okay, so the two of those numbers multiplied together be negative 48, but then when you add them it's negative 13. So I'm going to rewrite this to be x squared minus 16x plus 3x minus 48. So now I have 4 terms, which means I can factor by grouping. So here, I'm going to take that half right there. Is there something in common between that half? Well, there's a x. I can factor out an x, like that. And then I'll be left with x minus 16. And then right here, on the right side, is there anything that I can factor out of that? And I believe is 48 divisible by 3? 48 divided by 3. It is. It's 16. So I can take out a 3. So I'm going to do plus 3, and that means this is going to be x minus 16. So now we have two terms, and they each have a common binomial factor of x minus 16. So I can factor that out. So I have x minus 16, and left behind is the x and the positive 3. So x plus 3. Now remember that we made a substitution that x is equal to y cubed. So let's substitute that back. So now I have y squared minus 16 times by y squared plus 3. So I just substituted back into what we originally had. And one more time I can break this down, because this is equal to y squared minus 4 squared, and then that is equal to y plus 4 and y, not 4, sorry, that's actually y plus 2, right? No, it's y plus 4, and then y minus 4. And then we have this term right here. So y squared plus 3. So right there, that's factored completely. So for number 6, so this has 4 terms, 1, 2, 3, and 4. So I'm going to do factor by grouping. So right there, I can factor out a 5p. And behind, I will have, I should have p squared plus 5 minus, and I can take out 5 from here, so 5, this is going to be p squared plus 5. Now they have a common binomial factor of p plus 5, p squared plus 5, so I can factor that out. So then I have 5p and negative 5, and then the p squared plus 5 that I factored out. So let's see here, can I factor any of these out? So from this term right here, I can factor out a 5. So now I have 5 and I have p minus 1, p squared minus 1, because I took out the p squared. Oh wait, not quite. No, yeah, it is p squared. Okay, so p squared plus 5, no, yeah, I think that's right. Oh, that's where I'm wrong. Right here, I took out a p squared. That's supposed to be, from these two terms, I could only take out a p, 5p. So I only took out 5p. Okay, so that should be 5p right there. So this is going to be p minus 5, and then p squared plus 5. And that should be it right there. That's about all you can do. Now to number 7, right here. So this one's a little bit tricky to see, but I do know by looking at the coefficients that these two numbers have a 10 in common. They're both divisible by 10. So I'm going to start there. I'm going to take out the 10. So now I have 81k to the 4th power minus 16. So 81k to the 4th power plus 16. So again, I'm left with something to the 4th power, but can I change it so that it's something to the 2nd power? And I can. So I can change this to be 10 times by, well, I know 81 squared is, or square root of 81 is 9. So I can change this to be 9k squared squared. And I can change this to be 4 squared. So now I can change that from one of the pattern at the top, the difference of two squares pattern. I can change this to be so it's going to be 10 times by 9k squared minus 4 and 9k squared plus 4. And again, I can continue to break that one down because that is the same thing. So I'm going to rewrite this to be 10 times, that could be 3k squared minus 2 squared times by 9k squared plus 4. And I can break this down to be 10 times by 3k minus 2 and 3k plus 2, and then 9k squared plus 4. And that should be it right there. So again, a big key is noticing how you can rewrite your factors and then using the patterns that we have above. Okay, so we have 4 terms here. I'm going to start by factor by grouping. So for the first 2 terms, I'm going to take out an a cubed, and then I'll have a squared plus 1 left behind. Take out a minus 1, which is the only thing I can do, and again I'll have a squared plus 1. So they have a common binomial factor of a squared plus 1. So I'm going to take that out, a squared plus 1, and when I do that, I'm left with a cubed minus 1. Okay? Now, again, looking for or thinking about any patterns that we have. Let's see what we can do. So, nothing really up here. But I could use one of these ones right here. See how these are being cubed. So can I rewrite one of those to match one of these ones right here? The sum or the difference of 2 cubes. So I can change this because 1 cubed is still the same thing as 1. So now I have the difference of 2 cubes. So I have a squared plus 1. And now I know that I can change this. Again, the difference of 2 squareds, where I have a cubed minus 1 cubed. So then a will be a, but b will be 1 now. So I have a minus b. So it's going to be a minus 1. So I'm breaking this down right here, by the way. That's what I'm breaking down. That's equal to a minus 1 times by a squared plus a plus 1. And there you go. So for number 9, I have 2x to the 6th, 8x to the 5th, 42x to the 4th. Well, first thing I can do is all of these are divisible by 2 and by x to the 4th. So I'm going to take out a 2x to the 4th power, and left behind I'll have x squared minus 4x minus 21. Okay, so this one should be pretty straightforward. So 2x to the 4th, and this I can break down into 2 factors, and the factors have to multiply. They have to multiply to be negative 21, but add to be negative 4. So those 2 terms would be x minus 7 and x plus 3. Multiplied together, these 2 terms will give you negative 21. But then whenever you take these terms, so x and 3, that's going to be 3x, and that's going to be minus 7x. Together it will give you 4x, which is what we have right there. Negative 4x. Okay, so that one's pretty easy. For number 10, so 4 terms, so again I'll factor by grouping. So right there I can take out a z squared. I can take out a 5z squared actually. And I'll be left with z plus 1. And right here, factor out a minus 6, and I'll have a z plus 1. So I have a common binomial factor of z plus 1. If I factor that out, I'll be left with 5z squared minus 6. And I think that's all I can do for that one. Let's go to the next page for number 11. So I know that this is 3, so can I factor anything in common here? I can factor out a 2. And then this would be 6x squared minus 11x minus 10. Okay, so here a is not equal to 1, so I can't just simply find 2 items that multiply to be negative 10 and add to be negative 11, but I can do something similar. So instead I'm going to take a times c, okay, that multiplies to be negative 60. So now I want to find 2 numbers that multiply to be negative 60 and add to be negative 11. So if I think about that, let's see, let's break this down. 60 can be multiplied by 1 and 60. Well, that won't give me 11. 2 and 30. And that won't give me 11. 3 and 10 still doesn't give me 11. Let's see, what else? 5. And so if we divide that by 5, what is that going to be? What about 4? If I divide it by 4, so 4 and 15 goes into, those are multiples of 60, okay? And right there, I can actually get negative 11 from here if I have negative 15 and positive 4, okay? So I'm actually going to change this equation to help with my grouping. So I have the 2 right here, and I have 6x squared, but I'm going to rewrite this term right here to be minus 15x plus 4x, okay? Because these two together gives you negative 11x, and then minus 10. So now I have 4 terms right here, and I didn't change my equation, so I can actually factor by grouping now. So here, between 6x squared and 15x, I can take out a 3x, and left behind will be a 2x minus 5. And then from these two terms, I can take out a 2, so plus 2, and I'll be left with 2x minus 5. And thus I have a common binomial factor. So I can take out the 2x minus 5, and I'll be left with 3x and positive 2. So 3x plus 2. And there you go. That should be that factored completely. Okay, so for number 12, is there anything we can factor from these two terms? They both have a 3, and they both have a m squared. So I'm going to take out 3m squared. So if I take away 3m squared from there, I'll have 1 minus, I think that's 16m to the 4th power. Alright, now are there any special patterns that we're aware of? Not if it's anything to the 4th power, but I can change this so that it's 3m squared, and then I can change this so that it's 1 squared, because 1 squared is 1, minus, and I can change this to be 4m squared. Sorry, excuse me. I can change it to be 4m squared squared, because that will give me 16m to the 4th. So now I have a difference. So now I have 3m squared, but I can rewrite this inside to be 1 minus 4m squared, and then 1 plus 4m squared. And then again, I can break this one down, because this is the same thing as 1 squared, so now I have another difference of squares, where I have 3m squared, and now I have 1 minus, well, first thing, I guess before I do that, I have to recognize that I have to rewrite this to be 1 squared minus 2m squared. Okay, so now I can rewrite that. So now it's 3m squared, 1 minus 2m, 1 plus 2m, and then I have this term right here, 1 plus 4m squared. So I know I went through those really fast, but again, I just need you guys, if you're having troubles with it, just go through, rewatch it, pause the video where you need to. But if you feel like you know your stuff, then I guess you're okay. So the other half of this video is the factor theorem. So the factor theorem is related to something that we learned in number 3.3. In number 3.3, we learned about the remainder theorem. So these are actually really closely related. Okay, so in the remainder theorem, we basically just said that to find the remainder, you can just plug a value into the function, and you can find that remainder. Okay, so similarly, right here, the factor theorem says that if this is a factor, if x minus k is a factor of a function, then f of k is equal to 0. Will equal 0. So basically, right here, so for these examples, it says show that a binomial factor is a factor. So here's a binomial factor that it's given, and it wants to know if this is a factor of this right here. And we can figure that out by saying, well, take the opposite of this, so x plus 1 equals 0, right? If this is a factor, then it's equal to 0. So then that would mean that x would equal negative 1. Okay, so if we plug that into the function, so f of negative 1, well, we get negative 1 cubed minus 13 cubed, 13 times by 1 minus 12. Okay, so if we do that, negative 1 cubed is negative 1 minus 13 minus 12. That's negative 1, so that's going to be positive 13. So positive 13 and negative 12 is positive 1, so I have negative 1 plus 1, so it's equal to 0. Okay, so I have proven from the factor theorem that this is a factor of this. Okay, so something that's really cool now that we can use is we can use the remainder theorem, because it says for here it's asking us to factor this right here completely, but it's kind of difficult to factor this one. It's not a very particularly easy one to factor. But what we do know is that x plus 1 is one of those factors. So let's use the remainder theorem to figure out the rest of this. So the remainder theorem, so if we know negative 1 is a factor, well, let's use synthetic division to find out the rest. So I'm going to take 1, negative 13, oh, I need a placeholder, sorry. So this is x cubed, and there's no x squared, so I'm going to put 0 x squared minus 13 and minus 12. And I'm going to use synthetic division, so I'm going to drop the 1 here. Okay, and then 1 times negative 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is positive 1. When I add those together, I get negative 12. And then when I multiply this with this, I get positive 12, and now I get 0. So basically, when I divide it by x plus 1, I get x squared minus x minus 12, with a remainder of 0, which means x plus 1 is a factor. So if I multiply this by x plus 1, I get f of x, what I had originally. Okay, so now I can factor this right here. So x squared plus 1 can be factored into x minus 4 times by x plus 3. And then I have x plus 1 from before. So that's how I would factor it completely. So I use synthetic division to help me factor it completely. So I'm going to jump ahead and try and do number 17. If you want to do number 16, you're more than welcome to, but I'll do one more example of the factor theorem so that we can finish this video. So for this one right here, it's asking us to see if x minus 5 is a factor. So if x minus 5 is a factor, then it would be equal to 0. Thus x would equal 5. So let's try and plug that in. F of 5, if we get 0 from this, then we know that it is indeed a factor. So we have 2 times by 5 to the 4th power minus 12 times by 5 cubed plus 6 times by 5 squared plus 20 times by 5. And that's equal to 2. Well, 5 to the 4th power, that's some big number. So 5 times 5 times 5 times 5. that's equal to 625. And we're multiplying it by 2. So times by 2. So I actually, from this term, this is equal to 1250. Now the next term is minus, and 5 times 5 times 5. So 5 cubed is 125, and if I multiply that by 12, I get 1500. 5 squared is 25, so 25 times by 6 is 150, and then 20 times by 5 is 100. So whenever I add all of this up, well, this is 150, that's 100, so that's 250, and when I combine 250 with this, I get 1500, and I'm still subtracting 1500, so then I get 0. Okay, so we've confirmed that x minus 5 is a factor. And now I'm going to divide this polynomial by x minus 5 to get the rest of my factor then. So, using synthetic division, I'm going to take 5, and then I have 2, negative 12, 6, 20, and I don't have a constant here, so I have to do a placeholder for my constant, so 0. Alright, drop the 2. 2 times by 5 is 10. That's going to be negative 2. And I multiply that by 5. That's going to be negative 10. Add those together is negative 4. Negative 4 by 5 is negative 20. That's 0. 0 times by 5 is 0. That add together is 0. So we don't have a remainder because it wouldn't be a remainder because this is a factor. Okay, so then the answer here is 2x cubed minus 12x squared minus 4x. Okay, and that is being multiplied by x minus 5 because that's the factor. Because we're trying to factor this completely. Now can I factor out this a little bit more? I can factor out an x, so then I have x. I can factor out a 2x actually. So if I take out 2x, then I have x squared minus, oh sorry, that's not 12x, that's 2x, sorry. So 2x, so minus x, and then minus 4 times by x minus 5. Now can I factor that out? And I can. So I have 2x, and those factors would be x minus 2, and I think x plus 1, and that isn't 4 because we factored out 2, so that's going to be 2 right there. And then x minus 5. And there you go, that's how you would factor that completely. So factoring, a lot of this is it's a lot more advanced techniques and trying to understand and see patterns and everything, and then using the factor theorem is also really helpful. So I know this is a long video, hopefully it was beneficial, and if you have any questions, come see me in class or just email me.